Good afternoon. I'm Diane Cleveno, and I will be presenting a lesson on triangle shortcut similarities. I am having to condense this lesson a lot. Originally, my lesson plan was written for a high school level, and our high school classes are about 80 minutes long. So I am going to be a lot of times where the students would have time to work, and I would be going around to assess their work and go over things. I'm going to be just cutting that time out. I would be circulating. I would be asking the students questions, but under this time limit to make this video, I'm unable to put all of that into this lesson plan. When the students walked in the room, they would have a do now on the board, which is an activity that they're supposed to do right away in their do now binder, and also posted on the board would be the daily objective. And today's objective is I will be able to use side, 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 angle, angle, and side, angle, side shortcuts to determine triangle similarity. They would take out their do now page in their binder, and they would copy down the objective, and they would also get started on the do now. And at the end of the time, when about 5 minutes that they would have to work on their do now, I would ask the students, okay, now we've done our do now. Our instruction was to solve for x. What information is given? Tony? Okay, yeah, we are given that triangle ABC is similar to DEF, and this sign right here means similar. What else were we given? That's right, we were given several sides. We are given that segment AB is 6 units long, segment DE is 9 units long, and I know that segment AB is similar to segment DE because they're both in the first and second spots of our similarity statement. So by doing that, I know I can find the similarity ratio. All I need to do is set that up, because what I'm going to label, let's label small, medium, large. DE is small. EF is similar to BC, so this is my medium, and this is my large. So I'm going to set small over small, and my X is on my medium, so I'm going to go medium over medium. Small left is 6 over 9, which is my similarity ratio. Can I reduce that? What would I reduce that to? Yep, you're right. 2 over 3. My similarity ratio is 2 over 3. 6 over 9 equals 8 over X. If I do plug that into your Desmos calculator or do your cross multiplication, what do you get for an answer? What did you get? How many agree with her? If you agree with Tony, thumbs up. Not sure? Oh, I think everyone's agreeing with you. Our answer will be 12. X equals 12. Now, I'm going to leave this up here right now for a little bit, because this problem right here is going to bring us into our first similarity shortcut of today. If you get out your notes from yesterday, the similar triangles, go right over to the back and you will see today's notes, similarity shortcuts. We're going to have side, 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 angle, angle, and side, angle, side. We're going to start with side, 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 move on to angle, angle, and then our third and final one will be side, angle, side. Those will be the 3 things we're doing today. So we're going to start with side, side, side. I will erase this. And I'm going to erase this, but I want to, let's see, we said that we figured out X is 12, so we can put that in there. And otherwise I'm going to get rid of this. And I'm going to keep our ratio, I'm just going to put it over here, 2/3. Now, we know in similar triangles, the ratios all have to be the same. So if I am given two triangles, and now basically our question today is, I'm going to give you two triangles, and you're going to tell me, are they similar or are they not similar? If they are similar, the similarity ratio needs to be the same on all three. So if you were given a triangle with three sides, first step, label your sides. And then we're going to say small left over small right has to equal medium left over medium right. And then large left over large right. Here I'm going to plug now. Third step. What do we do next? That's right. Once you get it set up, all we do is plug our values in. Same as everything else. So we plug in our 6 over our 9, our 8 over our 12, and our 10 over 15. Now, I need to find out if those are equal. How can I find out if those are equal? How did we do it earlier? Here. That's right, you reduced it. You found the common factors and reduced it. You can do that. You can do that. But if you don't want to, if you don't need to. How you can do this is get your calculator out, get onto Desmos, log on to Desmos, and divide this for me. What is 6 divided by 9? Yep. 0.6. Yeah. So let's just 0.6666. So let's just make 0.67. Can somebody else do the next one? And then Keandra do the third one for me. What do you get, Daquan? Yep, 0.67. Keandra, what do you get? Oh, 0.67. So, if all three sides have exactly the same similarity ratio, and this is in your notes right here, if all three sides have the same similarity ratio, then the triangles are similar. That means it's a big me and a mini me. The triangles are similar. What if I plug it in and you don't get the same number? What if I would have made this be 8 over 8? 6 over 9 equals 0.667. 8 over 8 is 1. They're not the same. Does it mean I did something wrong? No, it doesn't mean I did anything wrong. It just means that those triangles are not similar triangles. It's not the big one and the little one. They're not the same shape. Okay, moving on to the next one. Our next one is angle, 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 angle. And this time we only need 2 angles. So this is why we call it a shortcut. If I have one triangle here, and I have another one here, what do all my angles in a triangle add up to? That's right, they always add up to 180. So if I know this angle is 40 and this angle is also 40, what do I know this angle is? This angle is 100. What about this one? If I know this is 100 and this is 40, do I know what the other one is? This one is also 40. So if you have 2 angles that are similar, are congruent, then you have 2 triangles that are similar. And how we would solve this, how you might see this in a problem is here. Let's look at this. I'll have a 50 here and a 40 here. Can I prove these triangles similar? Maybe. Let's see. What do I know? Let's see. Hold on. I must say 50 here. If I have these two 50, can I prove them similar? Maybe. Let's see. I've got one similar here, one similar here. I only have one similar angle. Where is my other similar angle? Think back to lines and angle. Our very beginning of the year, lines and segments and angles, our very, very, very first, way back, October. What did we know? What were we always remembering to look for? That's right. Look for your vertical angles. I know this and this. They are vertical angles. They are congruent. So I have one set of congruent angles here and another set of congruent angles here. That is enough to prove that these are congruent. The third method is, so we're going to put this right here in our note, on our notes. The second one, we moved on to angle, angle. If a pair of triangles has two congruent angles, then the triangles are similar. At that point, I would do another exercise on the whiteboard, another guided practice with the students, and then I would move on to side, angle, side, where I would demonstrate you needed to put those two methods together. You needed to use the ratios, have to be, the similarity ratios for two sides needs to be exactly the same, and then you need one congruent angle between those sides. Hence it's called side, angle, side. I would do a couple guided practices with those two. So then we would have side, 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 angle, angle, and then side, angle, side. We would do guided practice, and I would answer questions and finish this worksheet out. After this worksheet, we would move on. Okay, now that you have all your notes on this paper, I would like you can use this. I want you to use this. We have the reference material here. In fact, I'm going to leave it up here on the board for anybody who needs to go back to this, or if there is something you're missing, please come up and get it. Now we are going to do, you're going to work with a partner, and you are going to tell me if triangles are similar. You are going to use your three shortcuts, angle, angle, side, angle, side, and side, 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 to tell me. Like on this card, for instance, we have a card that has three sides. You're going to set up those ratios and try to solve it and tell me, is that ratio the same? And if it is, on this card for number 3, you're going to write yes, they're congruent, and you're going to tell me why. And for this one, it would be, you're right, side, side, side. If the ratio isn't the same, you would write not similar. Now, you're going to be working with a partner. I want you and your partner to both put your names on these. What you're going to do is each pair is going to get 4 cards at a time. You're going to work with your partner. You're going to figure out your 4 cards. And then when you get that answer, you're going to bring it up to me or Miss Rubidoux or Miss Cooper, one of the 3 teachers in this room, and we'll check over your 4, and then we'll give you 4 more. So hopefully by the end of the hour, you'll have all 24 filled in, all 24 worked out with your partner, but we're only going to do them 4 at a time. You're going to do 4, come up, get checked, and then we'll give you 4 more. So this should keep you busy for the rest of the hour. When you're finished, make sure both names are on here, and you can turn it in the turn-in basket. Now, can I have someone help me pass out these papers? And then Miss Cooper will come around and give each pair a set of cards to get started.